Hello, everybody. Hope you're doing well. Today, I would like to make a very small, simple project, nothing too crazy or fancy. To this, one of the thoughts that I'm having recently, and that's basically to create a program using fewer files. So usually, the common convention is that you want to split your code across multiple files. Um, But what happens if we go the other way around, right? What if we try to keep it to the minimum, um, hopefully to just one file? And I know, like every recommendation or good practice or whatever says that you wanna create multiple files, keep everything tidy, small, so on and so forth. But if you think about it, or at least um, I got some conclusions from analyzing this thought. So these are some of the pros that I could find, and let's go through each one of these. So ideally, as I said, only one file or um, a considerable amount of reduced files, which leads to less guessing on where the things are, right? You know that you got your main file or something like that, and everything is in there. You don't have to open a lot of tabs looking for or folders looking for what you're looking. Arguably easier to read. Uh, Hopefully, I guess. I think this is something that we will find out after this experiment. But yeah, basically think about it. It's like reading a book. You got the whole thing in just well, in the book. You don't have to jump from book to book to read the whole thing. Easier to search for things. You can just Control F and that's it. You can also combine this with a two-column layout. So having the same file open on the left and on the right, and then on the left or whatever, on one of the columns you make the changes, and the other one you use it. Um, you can use it to search or read for documentation. Less distractions. When when you're creating a new file, usually you have to write a lot of, well, hopefully not a lot of boilerplate, but usually there is a little bit of boilerplate, right? Uh, in the case of C, you have to deal with some macros, if and def. In other programming languages, probably you just need to include or ask for the dependencies. But the thing is, every time you create a new file, you have to think, well, where do I want to create this new file? Where would it be like a good place for it, especially for big projects? Then you have to deal with the boilerplate. And if you're on Java or C, you have to create two files actually. One is the header. In Java, that would be the interface file, and then the class or the implementation file. And you may think that's not a whole lot of things, but the main problem that I found with that is that it breaks you from the flow. Because you may, so this is what I'm thinking about this. You're writing code, right? And then you think, oh, I have to create a new file. You go through all that, and then you go back and you have to go back and forth um, on what you were doing. Do you know what I mean? Instead of just writing the code, writing the function just right there. And this is especially annoying when you got a lot of folders and you have to think where do you want to put the um, the new file, where does it look tidy, things like that. And that's like it adds um, as a distraction. The next thing is cyclic dependencies. This is obviously easier to get fixed. You just move the functions and that's it. And easier folder structure, almost none. Now on to the cons. Well, obviously after every change you have to compile the whole thing. Um, Namespaces, name conflicts, and the IDE can explode if the file becomes too big. Um, but if you're using just a text editor like I'm doing, uh, you shouldn't have this problem at all. So let's go ahead and give it a try. Let's see. Layout. Let's begin with the first thing, and that's the layout stuff. So this is what I'm saying, right? You got one column where you can write all the code, and then this second column where you can check for documentation, right? So let's say for now, well, first let's see if I can use, well, I think I didn't even mention what the project is. So basically, I just want to draw a texture. I'm going to follow the Learn OpenGL guide and up to the textures section, and that's it. Okay. And now this is not a big project. Like, obviously, dude, like this is gonna look good in small projects. Um, but I think we will be able to see some glimpse if this is not that great of a of an idea, right? So of course, this is not gonna m match a workflow for big projects, but at least it's gonna give us some indication of if this is really worth it or not. Okay, so let's see if we can run these functions. Hopefully we can. Um, can I build? Seems like yes. One file. Nice. Seems like it's working. For the build script, I don't have anything fancy, just some flags, including the dependencies and executing, sorry, and compiling the whole thing, right? That's pretty much it. This is just all following the guide, but since that's boilerplate, I didn't want to include it in the video. Okay, so now let's, just for the sake of it, let's separate this thing into its own init function. And yeah, let's go ahead and say void init window, something like that. There we go. And then I guess we can do void init window. We're gonna ask for anything here, and we're just gonna copy and paste, cut and paste this. Then init window. Okay. Now, what if you if you got a capable IDE and it works well, you can easily check on the type definition or the definition and then the implementation, right? In this case, well, maybe I'm not using this properly, but you know what I mean. Sometimes you want to read the documentation, just the signature of the function or whatever, and in other cases, you want to read the whole implementation, right? You want to tackle or you want to check whatever. You want to see the implementation, right? You know what I mean. So here it's a bit complicated because if I search for init window, yes, I got the definition and then I got the init window, the actual code. Imagine that I got multiple calls here, and then the search is gonna become a bit annoying because no, I don't want to search for calls. I just want to search for the implementation and the declaration. So how can we overcome that without relying on the IDE? One of the solutions that I came up with, it's just basically using macros. So we can say declaration, and we can say implementation. Then every time we uh, create a function, we can say declaration and then implementation down below. So now we can do that. And then if I want to read the implementation, I just do implementation init window. There we go. If you want to list all the implementation that you got, you just search for implementation space, and that's it. Okay. Um, okay. Now, the other thing that I was thinking about this is that we may have to consider prefixes more carefully. In this case, what if I want to read all the functions for window? Um, and I guess we can get something better if we do window init, you know, and then window init. There we go. Window init. Whoops. Okay. So now if we want to search for all the code in the window related uh, thing, we just search for implementation window. That's it. Or declaration, whatever. Okay. So now let's leave that. Let's remove these spaces. And let's continue with the guide. Hopefully it's not that complicated. Okay. So what do we have to do here? We're creating the window. That's fine. And then I don't want to use nulls, just 0. It's easier. And then I guess we want to have the window to be a global. And for that, maybe we can do something like types.h. So again, this becomes easier to, or not types, or well, yeah, types. And then we can do globals.h or something like that. There we go. So now if we want to add a new global, we just globals.h. There we go. Okay. So let's go ahead and do that. Cut that window 0. There we go. And maybe want to do static. Static. Do I have to add a static here? I think I do. Okay. So now we can do window. Hopefully this compiles. Seems like yes. Maybe we can include this code in this function, right? Okay. And since we shouldn't need the we don't have to look out for files, so we should be able to just crank that up. Okay. Let's continue. Okay, we gotta check for this. If we don't have a window, we'll have to exit def, and then there was an error creating a window. Okay, we can create, I'm assuming we'll have to include a lot of files, so I'm gonna add a anchor comment in here as well, so it includes that age. And now I have to include stdio. There we go. So far, so good. I kind of like the flow, so we're getting there. Okay. DLFW terminate. No, I don't think I'm gonna call that. Okay. So make the current context. Uh, okay. So now we have to load glad. Maybe we can change this. So I can say int, and now like so. So now I can do if we don't have a window, we'll die, and we can do the same for int declaration window glad init, and then here we can copy this. And I'm gonna do this. I'm gonna say if we got a window, do that. Now we will load this bad boy here. Okay, and what's the well, I guess I can just go ahead and do that. And then in here, I'm gonna say window init, window glad init. Okay. And I'm gonna do the same here. Printf enable load glad. Okay, can I compile? Declaration expected. Where's the problem? Line. What are you talking about? What's the problem? S3IO, that seems to be fine. Can I compile? I can't. 63. Could it be that this macro is already being used? I'm gonna say F, just wanna prefix this. F implementation. Okay, can I compile now? I can't. Oh, duh. I'm blind, bro. Okay. It's a bit annoying to remember to use these prefixes, but I guess it's fine. 37. What are you talking about? Oh, okay. There we go. Okay, so far so good. Viewport, okay. Frame buffer, okay. Hopefully I don't have to. We have to tell glfw we want to call this function on every window resize. I don't think I need to call this because I'm not gonna be handling that case, so. Alright, so now let's go into the loop. Okay. Maybe I can do something like static void game loop, something like that. And then remember to use the declaration thing. Go. And void implementation game loop. Then I guess I can do this whole thing and game loop. Okay. And then what else? Should check. Terminate. Yeah, I'm not gonna call that. Okay, so we should be getting an empty window from this. Look at that. Nice. And then we should be able to close it. Okay. Nice. So far so good. Input. I don't I don't know if I wanna deal with input. Process input. Well, I guess I can do some basic thing. I'm gonna do void game IO, or yeah, sure. So where should I put this? Okay, so seems like I gotta use this in here, so game IO. Then where do I want to put this? Guess I can do that. Game IO, void, and then I'm gonna copy this. What am I doing here? If we're pressing escape, we're gonna exit. That's good. Game IO, can I compile? Yes, nice. Rendering, process input, pull event, swap buffers. Okay. Hey, nice. Let's go ahead and do some clearing. Where's this supposed to go? I think it's here. Okay. Can I run this? Yes. All right. Now, next or hello triangle. Okay. Go with some vertices. Or you know what? I think we can do like static void game declaration game test triangle, something like that, and then game test triangle. Okay. And now static void implementation game test triangle. Paste it in. All right. Uh, okay, so we bind it. We bind the buffer and then, sorry, we generate the buffer, we bind it so we can use it. And then what do we do here? Like, are we sending the data to the GPU? I don't know. Okay. Right, let's do this. Vertex shader source. Okay, I'm not gonna change anything. I'm just following this. Okay. I don't want to use uppercase though. BBO. And that should be fine. Vertex shader. I think we have to check for errors when we create a shader, but for now, I'm gonna omit that. Shader, shader source, and 0. So far so good? No. Uh, because this is not sources. It is SRC. Alright, so far so good. You probably want to check if completion was successful. Yeah, this is what I gonna be skipping. Now the fragment shader. Fragment shader, create shader C, and no, we don't want to use nulls. Okay. And this is the fragment shader. I'm gonna do something like this. Fragment shader. And what do we need? We need an output, version, and then up. Okay, like so. Have to be very careful not to mess this up. There we go. Nice. Okay, so we got the fragment shader and the vertex shader. There we go. What else? Create the shader and then compile it. Yes. Now we gotta create the program. 0. Okay. And we have to attach it so we can use it. In order to do that, we attach the vertex shader and the fragment shader to the program we just created. Link the shader, and then uh, we link the program, sorry, and that's what we're going to be using when we draw calls. I think that's the flow. Like, I'm very new to OpenGL, so take whatever I say with a grain of salt. Okay. There's a lot of steps that we will wanna uh, move to its own function. So, okay, so now that we got the vertex and the shader and the fragment shader linked to the program, we can delete this shader and fragment shader. All right. Now we can do this. I think in here we have to send how many. I'm gonna add a trusty line RLN x. This is gonna be size of x divided by size of x. There we go. So now I'm gonna say, instead of doing this, I'm gonna say array len of the vertices that we want to draw. This is going to be float, balls. I'm not going to use this. I'm going to say size of vertices. There we go. And I'm not sure I have to use this. I think I can just say 0 and that's it. There we go. Sum of integer transfer triangle. Okay, so this we did this already, right? Find the buffer. Yes, there we go. Attrib, vertex attrib. Yes, what we just did. Enable. We gotta use the shader, although yes, we're already doing that, so we don't have to do this. Okay, apparently we need something else. And oh my goodness. Okay, we're getting there. BBO. Size of vertices. Okay. Do I really have to do this again? Like, doesn't seem right. Vertices. Size of vertices. Am I being trolled by the guide? Maybe. Then we enable this. Okay. And we bind it. I think, yeah, something is not quite right, but continue with this. Okay. We bind it, and now we should be able to draw this. Okay. Now, if I run this, we should see the triangle, and we don't. Why not? Let's check on the code. What am I doing wrong? Okay, I think this is where. So we got that. Hang on a second. So where game loop? Oh, okay. So we have to do this after we clear this. All right, how about now? Still not quite there. We clear, we use that, we bind, we draw, and then we swap. Um, then where is the problem? I think I'm gonna use, okay, let's say static void declaration game. How can I call this? Create vertex shader. Create fragment shader. And then below this, no, game test triangle. So below this, I'm gonna write all the logic for creating the game create vertex shader. We get the vertex shader, there we go. Okay. I think this is pretty much it, and then I have to return unsigned int, and that's gonna be the vertex shader, I think. Okay. So with that, yes, that should be it. Now let's do the same with the fragment shader. Game create fragment shader. Okay, and get me the source. Perfect. And then unsigned int here as well. And don't forget to add the implementation prefix. The same here. It is very easy to forget the prefix, but I guess it's just a matter of getting used to. And then I have to return unsigned int in here. Okay, so now we can clear this up a bit. Shader program. I guess I can do that as well. So unsigned int, game create shader program. Sure. And then unsigned int, b, and unsigned int, f. B for vertex, and the other one for fragment. Okay. All right, and now let's get this static void unsigned int implementation. Don't forget it. Game create shader program. There we go. And I'm gonna add a new typing here because I'm gonna try. I'm gonna go crazy if I keep typing unsigned int uint. There we go. Then we can replace this with uint. Lovely. Type def. Okay, so now I can do the same here. uint, uint b, uint f. Shader program, we can do this as well. Uint, there we go. B, f, link, use, delete, and return the shader program. And grep. Okay. Uint, clearing, cleaning this up. Uint. Okay. Now that we got that out of the way, we are creating this. We are creating this as well. Vertex point. Okay, let's check on the code to see what's the proper steps for this. Okay. Um, this is fine. Fragment shader. Okay, so first we have to create the shader program. So for that, I'm gonna use vertex, create game, create vertex, and the fragment, game, create fragment, and then program, game, create program, vertex, and fragment. Okay. After that, we create all of this. Before that, let me check on the program. Okay, yeah, so I don't know. Sure, let's leave these two calls. All right, so we create those, the program, and then we bind the array, the VBO, although I think we have a difference here. We have to generate the BAO. Perhaps I can, yeah, let's go ahead and do this. All right. So first we do the BAO. Then we generate the BBO. Then we bind the BAO. Then we bind this buffer. Then we do this. Okay. This. And here I don't want to use this. I want to change to be array len vertices float. Then we don't have to do this. We can just say vertices. And I'm going to send 0 here. Okay, then we do this. Bind it. Okay, I see. Then we can get rid of this. Okay, I think the we have to call this before this. And then in here, we clear, we use the program. And now we can draw. But I don't have um the shader program nor the BAO. So how can I do this? Well, maybe we can use the global for now. I'm gonna do this and this. And then vertices. There we go. And now um, I have to make this a global. Not ideal, but this will do for now. What else do I need? The BO. And you know what? I'm gonna copy this, keep it in here, but I'm gonna leave it commented. Toggle. There we go. What was the other one? BO. Do the same here. Okay, and what else? The shader program. Okay, so I'm gonna change this to be shader program. And then we use the program and shader program. Okay, static uint shader program. Okay, so now we begin with the we initialize those variables and the shader program, and then we try to draw it. Let's say now buttocks shader undeclare 163. Right, this should be B and F. Okay, so now we should have a triangle, but we don't. What am I doing wrong? Could it be that we have errors in the shader program? I guess I'll have to... Okay, let's add the vertex. Okay, so when we compile the shader, we can check for this, and then status, what's supposed to be status? Int. Okay, if not success, or maybe we can do success, but was successful, else we'll print this. Okay, and then buttocks shader problem. Okay. Vertex was successful. Okay. And then let's do the same for the fragment. I think the code is pretty much the same, but just to be sure, I'm gonna copy the exact same thing. So vertex shader, I'm sorry, fragment shader. So if it is success, I'm gonna say printf. Fragment was successful. Otherwise, um, this off log 0 log and this out. Fragment shader problem. Okay, let's see if everything is correct. Vertex and fragment was successful. And we have to check one more, which is the program. Okay. So when we link the program, we can check. Oh, what am I doing, bro? I'm not setting the global. Yeah, I'm not setting the global variable. What? I guess that was the problem, but since we're here, let's add the error checking code. Okay. So shader program. This. I'm gonna do printf. Shader program was successful. Okay. Otherwise, gonna log this. Get me the program. Data program. Size of log. Come on, jump to the next. Okay, printf. Shader program error. Okay. So let's see if now it works. Still no, but at least we know everything is loaded properly. Alright, so we attach this, we link. Let's get rid of this. And then I'm gonna say generate bind. Yes. And then where's the draw use program? Yes. DAO. Vertices. Oh, hang on a second. I think this is not. Yeah, this is not correct. Whoops. We don't want the length of the array. We wanna. Yeah. We want to pass how many points or vertices we want to draw. All right. And then, what else? I think we may have a problem here as well. Buffer data, size of vertices. Okay, this one is fine. And what about the vertex attribute pointer? I think this is incorrect as well. Yeah, this one should be 3. Okay, what about now? Still not quite there. What's the problem? What am I doing wrong? Find vertex array. Clear, use the program, bind. Game loop. So we set this thing up. We clear the color. We use the shader program. Find the VO, and we should be able to see the triangles, or the triangle. Implementation, game test triangle. Data program, DAO, uh, let me check on the sizes. Perhaps I'm doing something wrong there. Why shader source? Let's check on that as well. We got this. Create shader. Yeah, seems like we're doing the same thing. Vertex 1. Okay, compile. And what about the fragment? Are we doing the same thing? Fragment shader. Okay, this is vertex. Okay. Fragment shader, fragment shader, fragment shader. Generate buffers. Okay, let's go through the whole thing again. BO, generate vertex array. Okay, generate buffers. Yes. Bind vertex array. Yes. BO. Yes. Buffer data. Buffer data. Vertices. Vertices. Yep. Attribute pointer. Okay. Um. So one of 3 vertices. And I guess I'm gonna copy this as well just to be sure that I'm not doing anything stupid. Okay, enable the vertex. Find the buffer. Yes. Find vertex array. Yes. Now clear. Clear the color. Do the clear, use the program, bind, and then draw. Swap the buffer, and this should work. Hey, look at that. We got a triangle. So where was the, like, let's change this because this should be the same, right? Or am I going crazy? It's not. What? Why is not the same? Oh, because it's, hang on a second. Why is this not the same? Oh, because this is, okay, so apparently I only have to send, it's a bit weird. Whatever, I'm gonna leave it like that. 0, compile, does it works? Yes, it does. Awesome. How is this looking so far? Um, I gotta say the flow doesn't look that bad. It can be a bit overwhelming when you're like in the middle of the file or something like that. But if you remember to use the implementation thing and the several anchor uh, comments that you may have, I think it's easy to navigate. Yes. The other thing is, it's nice that since I'm having all the declarations at the very beginning, um, I'm not forced to write from the bottom to the top. I can, I can do pretty much this, or I can read the code from the top to the bottom. That's nice. You don't have to use this flow to do that, but it's nice that we can do that here easily. Okay, let's continue with the tutorial. Okay, so now we're adding a new triangle. Oh, I guess this is, yeah, this is for the rectangle. Okay, let's add the rectangle into the mix. Although, I think I want to refactor this a bit. Using those global variables is not ideal. So how do I want to do this? Do I have to, when I use the program, do I have to destroy it? Destroy, like I don't know if I have to free resources, or am I supposed to load the program every time I want to use those shaders? I'm not sure. Delete shader. So do I have something like DL delete? Seems like I do. Delete program and then shader program. And then what if I do something like that? Okay. It works, but I'm assuming that's not the proper flow. I'm assuming we may have a dictionary or hash map pointing to these shaders, to these programs. So you compile once, and then, yeah, I guess that that makes sense. You compile the program once, and then you use that dictionary to fetch the reference or the handler or whatever, and then you use the program, and that's it. I think that's the proper approach to this. hmm So in that case, I guess since we will only have one shader, I don't think it makes sense to use the dictionary yet. So, okay, let's refactor this. I'm gonna say static void. Actually, game loop. Yes, I guess I can do static void game create shader or declaration game create only shader or create default shader. Let's say that. Okay. So now static void game create default shader, and I guess I'm gonna copy. I think we can take the source. There we go. Okay, so now let's go to the implementation of create, sorry, game create buttocks. There we go. Paste that in. I'm gonna comment this out. Okay, so we create the shader. We do that. Success. And then we'll return. Okay. Let's do the same in here, in the fragment shader. I'm gonna comment this. Okay. And then I don't have to use the global here. I can do uint program. We're gonna use the global outside of this function. So this one remains independent. There we go. And now in the game loop, implementation game loop, I'm gonna say before, and you know what? Let's move this below so we can continue with the, can read this more naturally if you want. So game create default shader. There we go. I'm gonna get rid of this call shader program. Um, I'm gonna update this, but for now, let's leave it like that. So create default shader, and now let's copy this, toggle, and do the same for the fragment, toggle, and now we can do. Now we're gonna use the global shader program and game create shader program, and we're gonna be sending game create vertex shader source, and game create fragment shader source. Okay, so now we got the default um, shader to be used, and we can update this to just draw the triangle, which I'm gonna do in here. So game draw triangle. I'm gonna say that, and this is gonna be game draw triangle. So it becomes easier to read. Bold. Where's the here? Game draw triangle. There we go. Why am I having? Oh yes, we don't need to do this. We can comment. We can remove the comment. We can take that out. We can remove this and this because we're going to be generating everything in here. We bind, we do all of that, and then we use this. So we use the default shader, we bind, and we draw. And then we don't have to delete this. So in theory, 148, what are you talking about? All right. So this should be, oh, I'm not sure if I'm gonna have to send, hmm, okay. Let's hope we don't have to send a pointer to a pointer. Let's see. Hey, look at that. It works. Nice. So now we can remove this. We can remove this. And anything else? Why is this having an error? Not sure. Okay, so now it makes a little bit more sense. Okay. All right, so now let's continue with the tutorial. I'm gonna copy the vertices. There we go. Lovely. All right. So now we got the concept of indices, so we don't repeat a lot of data. All right. So this is another point where I can mess things up. EBO. EBO, let's copy that. Similar to the VBO, we bind the okay. So bind the buffer. So we first generate and then we bind it. I think that's It should go indices BO, and this is fine. Okay, find buffer. I guess, well, okay. So now note that we're not no giving element array. Okay, bind buffer. EVO. The resulting in initialization and drawing code now looks something like this. Okay, let's see if that's the case for our code as well. Buttocks array. Hello, hello. Okay. Buttocks array. Yes. BO. Bind buffer. BBO. Yes. Data. Vertices. Data vertices. Buttocks. Bind buffer. We have to bind an additional buffer. What? Oh, the EBO. Okay, so bind the vertex. So apparently this has to be first. Bind vertex. Yes. Bind buffer. BBO. Okay. Then we bind the EBO, which is correct. Am I doing this twice or what? I'm not. Okay. So bind the EBO, correct. Then bind the indices, yes. Then I guess we can get rid of this. Vertex attribute pointer, vertex attribute pointer, still false, 3, okay. We enable this, and then we draw. Enable vertex array, then we use the program. We bind the vertex array. We draw this. And finally, we draw this. In theory, now we should have a rectangle. We'll say, well, maybe not. So where's the problem now? Let's check on the code. We got all of this already. The vertices, I think we don't have the same. Maybe we do. Just in case, copy and paste. Okay. So we generate the EVO. Okay, seems like we got the order. You know what? Let's go ahead and remove that. BO, BBO, EVO. Vertices, EVO. Okay, and now we can to this, and we should be able to draw. Let's see now. Still not quite there. Oh, I think I'm not using the program. The Vine products, and then I gotta remember to use the program. Hey, look at that, nice. Now we got the rectangle, lovely. Get rid of this. All right, we're getting there. Can close this and yeah, we don't do exercises. Shaders. I don't know if I have to do anything in here. Yes, I don't. Okay, that's all fine, but I wanna draw a texture. Yes. All right. Okay, so let's begin the copy and paste stuff. Yes, this is all fine. I think I don't have to define this wrapping stuff. By default, I think it's repeat, but I could be wrong. I am going to set this to near, and I'm not sure where I should be putting this, but I'm gonna say here. Just like texture filtering, we can set the filtering method. I I think I can omit this. And then we gotta use the library from Sean. I don't recall his last name. Sean Verrett. Okay. Now, see, this is the thing. So now I have to create a new file, and where should I put this, right? That's a little bit of okay. And this is gonna be stdb. What was the name again? stdb image.h. Okay. Save. There we go. Okay. And now we gotta include this. stdb image. See, that's where we spend a little bit of brain power. Like, where should I put that? How should I organize this? Like, you're getting all of those small little thoughts that break you out from the flow. Okay. So now I don't have to, I have to do this. So we got the implementation as well. What is this? Okay. Generating the texture. Okay. I'm gonna add a new global, and I'm gonna say I'm gonna say static uint wood texture. Okay, and now in here I'm gonna say static void declaration game load default texture as well. Sure. And now below this, game default. Yeah, I'm forgetting the prefixes. And yeah, there we go. So below this function, default shader, I'm gonna create this one. Implementation, game create default or create, yes, default texture. Why is it not showing up? Oh, because this is load. Let's say create. Not gonna take anything. And let's see. Save the, where is my Franco one file? One file container. Okay. So first load the file. Nope, this is not how we roll here. Okay. I don't want to use unsigned char. I want to use byte. Go. So then I can say byte and number channels. There we go. I think I can check for errors in here. So if for some reason we don't, or maybe we can do printf container JP was loaded successfully. Else printf uh, there was an error loading the image. Okay. And now we can create the texture, which we are going to be using this global variable for. Okay. Wood texture. I'm gonna close this. I don't. Do I need it? Not really. I can update the build script to run the executing a file. Cd build start or one file.x. Okay, perfect. So we generate this. We bind the texture. What am I doing here? I guess we're setting, okay, everything up. And then we can free the data. Okay. And now we generate set the texture. I see. I don't, mm, again, I don't think I need to do this, but just to be sure, let's follow the tutorial. Um, Text generate, and then we have to apply this to the vertices. Mm-hmm. Okay. So when we create the default shader, let's also create the default texture. And then when we draw the triangle, we'll include the texture. Okay. And now we have to update this. Hopefully that's the only match. Yes. Okay, so I can copy and paste this. All right, and then what else? I need to update the fragment shader. Okay, so implementation, game, create, fragment shader. No. This should be game, create, default shader. Okay, so we got a fragment shader and we need the A pause. Are we sure this is the fragment shader? No, this is the vertex shader. Next, we need to alter the vertex shader to accept texture. Okay. So then we need the A pause, location 0, that's fine. The A color, and then this. Um, out, out. And then the GL position is gonna be A pause, like this. We're gonna include the color and this picture coordinate, finally. Okay. And then the fragment shader, what do we have to do here? R color, okay. Below, out, yes. So now we're getting some input variables. All right, and then the fragment color is going to be this. All right, and then all that's left to do now is to bind the texture. Okay. And then implementation, game draw triangle. Okay. I don't, yes, I don't have to do that. So in here, I'm I don't know if I have to do this either. I think I don't. So we bind the texture, which is going to be the wood texture. Do this, and we draw that. Let's see if it works. No. What's the problem? talking about? You have a problem in the library? What the fuck? mint. What? 7. Okay. How about now? Okay. So at least now it compiles, but and there was an error loading the image. Okay. Thank the good there image. Loading the image. Okay. I'm assuming that's the problem. Not quite. Oh, because this is going to the into the build folder. So I guess I can move. Can I move this? Cut and paste. Okay. So how about now? So now the image is being loaded successfully, but for some reason the image, the texture is not being drawn. Create default texture. Are we setting everything properly? Generate the texture. Yes, into the wood texture. Yes, this should be fine. Okay, let's click on the source code again. What about the vertices? Are they correct? They should be. What about the indices? 0, 1, 3, 1, 2, 3. Yes, this is fine. Okay. Generate vertex array, VL. Generate buffer, BBO, EBO. That's fine. Bind, BO, bind buffer. This all seems to be fine. Vertices, indices, position attribute. Oh, maybe this is where I dropped the ball. I guess I'm gonna comment this out. And after the indices, I'm gonna paste that. Okay. Then we generate the texture. That's fine. Bind. Yes, so far so good. Okay. And then to draw it, we have to bind the texture. I don't think we need to do this any longer. Nor this. Nor that. We bind the texture. Yes. We use the shader, which we're doing that in here. Then bind the BL. And then we draw this. Okay, so now hopefully we should. Hey, look at that. We got the texture drawn. Um, all right, I guess this is a good place to call it a day. About the flow, um, it doesn't look to be too bad. I didn't encounter um, scenarios where you you can easily tell now this isn't worth it or it like it's not ideal to work this way. I didn't encounter those cases. So maybe I guess I'll have to uh keep trying this flow, you know? Of course, again, this is a very small project, like, but the idea was to see if we can see some glimpses of, yeah, this is not worth it, this is messy, and that was not the case at all. Like, I actually enjoyed the whole flow. I enjoy not having to worry about creating new files, the boilerplate, and things like that. You do have to remember to include these prefixes if you want to easily navigate the code with just a Control F feature, but other than that, I think it's pretty good. Like, again, you wanna check all the declarations, you can do that. There we go, all the declarations. You wanna see the implementations? There we go, all the implementations. Do you know what I mean? What about globals? You wanna include globals? There we go, globals. And I don't know about you, but like not everybody has two monitors. Like I like the idea of having two monitors, but setting everything up, like I'm a bit of a lazy person, and I don't really want to do that. So yeah, I don't use two monitors. And this flow, like with this flow, you don't need two monitors, right? You can just use one, split it, and that's it. You call it a day. I don't know, guys. To be honest, I kind of like the um, this way of writing code. But I guess you can leave me the comments on the you can leave me some comments on the video if you enjoyed. And and yeah, I guess I'm gonna see you guys on the next video, which hopefully it's gonna come shortly. All right, guys, take good care.